All right, two variable data. That's when you're introduced to a relation. That's when we talk about independent and dependent variables, domain and range. That's our two variable data. Okay. Do these words all sound familiar to your lives? Awesome. So right here is an example of all the different ways you can represent two variable data. The first way is as a list of ordered pairs. I can list it out as a list of ordered pairs. I can make a graph of it. I can create a mapping. I can have a table. I can have a word problem listed out. But these are all the ways that I can represent two variable data, AKA a relation. Yes. All right. Now, putting it all together, what are the things you call these two variables? Well, thing number one, a lot of times we start off with domain. Domain is referring to our X values, our input, right? So domain, input, X value, independent quantity all stands for one of the variables, right? And next one is range. Range is the relationship that you're good of data is your set of output values, your Y values. Your range is output, your Y value, your dependent quantity, okay? I like to call them Dixie and Royd. I think of two old hound dogs sitting on a porch, don't know why, but those are their names, Dixie and Royd, okay? Domain and range, and it breaks down to their synonyms, okay? So using two variable means that you have two sets of data that are compared to each other and are related to each other, I'm sorry. So a physics class measures the time y that it takes for an object to fall, x feet, as shown in the table. The object was dropped twice from each height, and the data was recorded. So we want to express this data as a relation S. So if we want to express it as a relation, we have a couple options, right? We can graphically, ordered pairs is most common way. So if I'm going to express this, because it says that my X is my feet and my Y is my second, and I have to write it as that order, right? X comma Y, and stay alphabetical. Questions so far about taking a table and turning into an ordered pair. Cool. Okay. Note here that it's a set, and every set is going to have a name. So this is the name of your set, and it uses braces, and then you list. Next is identify the domain and range of our set. What is the domain of our set? The X value. So what is it? Okay, when you're listing out the domain, you do not repeat. 20 and 40 are my values of my domain, right? They may be used more than once, but they're the only values in my domain. Okay, my range, none of my values repeat, so I'll write them all out. And notice that it's in numerical order. Numerical order, it doesn't matter if it's in increasing or decreasing order, just as long as it's in numerical. All right, still good? Cool. Next, we're going to talk about the Cartesian rectangular coordinate plane, which is another way to represent a relation. Okay, that's now that we are taking our X and Y values and we are plotting those points. What we want to talk about here is where everything falls. So you have your X axis, your Y axis, you have your origin, where your X and Y intersect at a perpendicular point. Okay, we have our quadrants, and our quadrants are numbered counterclockwise. Quadrant 1, I didn't mean to write it there. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, other thing to remember is that you have your positive and your negative sides of the axis. To the right, those are my positive X values. To the left, those are my negative X values. Up are my positive Y values. Down are my negative Y values. Brand new, or are we good? We're good, right? All right, so here we have this. And it says you should already know how to do this, right? If we have this relation, and I wanted to find the domain of this relation, are you able to do that? Yes, we feel good about it? Do we feel good that this would be the answer? Does anyone need me to dive deep why it is? And then the range is the second number. And it's from least to greatest, right? Or greatest to least, as long as it's in numerical order, okay? Next thing, you should be able to determine what is the maximum and minimum of the X and Y values. Because when I separate it, if I talk about only one, it becomes single data, right? So what is the maximum and minimum of your X value? The maximum is for the domain 5, and my minimum is -15. For my range, bam, good. All right, and then if you wanted to plot it, at this point, are we all comfortable and able to plot points on a graph? Okay, awesome. You will get practice on that on your homework if you haven't started, but plotting points. Hopefully we all can plot points. Okay, remember when you're plotting points, if it is a positive and a positive, it should be in quadrant 1. If it's a negative and positive, it should be in quadrant 2. If it's a double negative, it should be in quadrant 3. And if it's a positive and a negative, it should be in quadrant 4. Okay, if you remember that, then you should be fine. All right. Questions about any of that so far? Oh my gosh, continuing. So line graphs. So we're at our line graph. Sometimes it's helpful to connect these points when you do a scatter plot, right? Is it going to always be helpful to connect a scatter plot? No, but most of the time it is. And when we connect them, we're creating what's called a line graph. So here's this example. We have this relation between months and prescriptions, precipitation. Precipitation of rain in Portland, Oregon. Oh my gosh, it rains in Oregon, guys. I went to Oregon once and it pretty much rained the entire time I was there. I thought people were joking about this rain business, but it's for real. Yes. Yeah, it legit rained. Also in Portland, you can't pump your own gas. What? You can't pump your own gas. Yeah, it's like a gas attendant has to come out and pump your gas. I don't know. It's like a law. Like you can't pump your own gas. Isn't that crazy? Like this gas attendant, like you really got to work. And it rains all the time. And it rains all the time. So like that just not the job for me. Yeah, like I mean it's like regular gas pumps, but still you gotta walk outside, gotta pump other people's gas. I hate pumping my gas.
But don't they have like a little foot thing that keeps it on there so you don't have to hold it on there?
I don't know. I didn't pay attention to it. I was just really surprised that the man was pumping my gas. I was just like,
so you went to get gas and what you got?
Yeah. Well, I was about to, and then it was like, and then the guy came, wait. I'm like, for what? And yeah. From out of I was like, oh, okay. We're not gonna steal gas here today. So, but yeah, line graph. So I graphed all the points on here, and looking at this graph, would it be useful to connect them? It probably wouldn't, but I'm going to anyway. So I connected them so I could see, okay, is there some type of correlation happening? What's happening here? And so as I look over the months, I see that there is a lot of rain starting at the beginning of the year, right? In January, there's like 6 inches of rain. Then it starts to decline. By the summer, there's less rain. And then it goes back up, which makes sense because I went in December and all it did was rain. And so it just helps you analyze the graph. And that's how you can use our beginning of 2 variable data. Questions, comments, concerns?